Number 37. All right, so we want this EH, CE, CB, and AB, not EG. So they're kind of all over the place. And when we get into these upper numbers of the problems, they're wanting us to use multiple methods. Method of joints, method of sections, whatever you want. So step one, free body diagram, we have that. Step two, choose our method or solve for the reactions if you know you're going to need them. Either one. So what did you do? Anybody have a strategy that they took? Okay, I think we talked about that last class too. So zero force members is definitely in there. Just be super careful that you don't like make them zero force when they're not. So kind of make them prove themselves to you. But I think it's a super good strategy. So I think we identified some of them last time, didn't we? Yeah. So they were anywhere you get a T. You know, if it looks nice and pretty like that, that's great. That's got to be zero because it's the only force in a direction. So thinking about a joint analysis, if you can see a T in whatever position, that's going to be a zero force member. So there's one here. If I draw the free body diagram of point J, it's JY down here, IJ up here, and AJ here, right? So if I said this was my X and this is my Y, then that has to be zero. The only force in one direction, or this is Y and this is X. Guess we could just leave it that way. So that's got to be zero. Based on this connection, not based on this. I can't look at this and say anything's zero because there's lots going on at A. But here, there's a nice clean T. All right, where else? D, yeah. I mean, I could just literally draw them in place like that and say, oh, some forces in the X, that's got to be zero. And some forces in the Y, that's got to be zero. So it's like you can take those members out under this loading condition. So anytime that happens, I like to move to the next connection to see if it's what I call contagious. Like, is that zero moving through? So if I look at C, right? And I say, oh, there's one here, and one here. Is there two in the X? Yep. Is there two in the Y? Yep. So it's not contagious. I cannot identify a zero force member at point C. So what about E? No, there's a little bit of chaos at E. There's a lot of unknowns. Anywhere else? F. F is a nice clean T. So this would go in, this comes in, this goes down. This is the only one in that direction. We have a zero. So yeah. So then I could go here at G and say, well, there's one here, and this. There is two in the Y, and there is two in the X. So therefore, I cannot determine a zero at G. So I think we're at the end of our zero force fun, and it may have helped us. Like, we're definitely not going to do a joint analysis of D, right? We're not starting there. No reason to. But it didn't give us any of the ones we want. It did simplify things down here a little. All right, now what? Solve for the reactions, and then what did you do after reactions? Joint analysis? Huh?
And then I ended up actually trying to solve the reaction.
Yeah.
Then
Yeah. Yeah, so that can happen. So it's good to like kind of have a strategy. I mean, you're gonna do probably more work than you should, no matter what, but if you forward think it a little, you'll do less work. So yeah, yep. So if I was gonna say, okay, I'm gonna do a joint analysis here at A to get AB, I'm gonna do that one. Then I would want to know these two reactions. I wouldn't really need that one, right? So, I mean, I guess I'm just saying, kind of choose a strategy and then go with that. I mean, I could also, do a cut here and then use the whole top part and try and get that. But I think that's going to be a little more complicated. Maybe not, because I could maybe do a moment here. And it wouldn't, those would be all easy moments, kind of. So that actually might be an easy way to go to get AB. Right? But I'm not going to do it. I'm going to get AX and AY and then do a joint analysis at A. And the focus is trying to get AB. Make sense? All right. So how do I get AX? Absolutely. How many forces do we have in the X? Yeah. So actually, we can by observation, and I'm good with this. Just leave me a little note. And that note is just in case you're wrong, right? But by observation, we can say AX is equal to 10K. They're the only two in that direction. AX has to oppose, oh, did I put it the wrong way? Yep. It has to oppose 10K. Everyone see that? I've done my job if that's true. All right, what about AY? Could. Yep. Because there are two unknowns in the Y. So that's why we're just not going to sum forces in the Y. There's two unknowns. So a moment about J. Absolutely. Yep. It's that line of action, right? So we take the moment from the line of action, not necessarily from the vector. And that line of action is right through J. So yeah, 24 drops out, JY drops out. So then we have AY times 8. And I drew AY down. That was my guess. So that creates the counterclockwise positive rotation for the moment. And then what else creates moment about J? The 24 drops out. 10K times. Yeah, remember it's that line of action. Here's the perpendicular distance. 8 times 3 is 24. Rotation. Spinning around that way, right? And positive. What else? 16 times. Yeah, line of action is here. Distance is here at 8. And rotation, bring it down here. We'll spin it around. Negative. Anything else create moment about J? What about this 10K? No. Goes right through it. We got the AY. 24 dropped out, goes right through it. We got the 10, we got the 16. I think we're good. Set it equal to 0. Algebraically solve it to see if it's plus or minus. I get 14. Confirmed. AY equals 14. Did you get plus or minus? Mhm. Yeah, so I get a negative 14 is what I get. I don't know if you can see that there, negative 14, because I took this, moved it to the other side, it becomes positive, right? Took this, move it to the other side, becomes negative. So the 240 is bigger than the 16 times 8 of a negative number. So it ends up to be negative. And we know, because I've said it a bazillion times, this sign means you assume the wrong direction, go change it. So AY does not go down, it goes up. And that changes the sign here to negative, which then makes this a positive, which we want. AY goes up. And remember, AY is a reaction. It's not a force in a member, so it's not compressive or tension. It's just a reaction that's doing something, right? It's going up. Now we know AX and AY, we should be able to do a joint analysis of A, which was my plan, so I'm sticking to it. Joint A, here it is. We got AY up at 14K. We've got 10K coming into the right. We've got AB, which is what we want to know, and AI, which we really don't care about. But it's there. And you notice I didn't put any arrowheads on there. I'm guessing that AI's got to do what? Direction-wise. Yeah, it's got to fight the 10K, doesn't it? So it's got to go in, but I don't know how big it is. So I really still don't know if AB goes up or down. My guess is it goes down, but I don't know that, right? So you kind of got to guess, like, well, can't really tell for sure, but I'm going to say it goes, pressure's on, I'm going to say down. And again, that's just a guess on AB. Pretty sure I got AI right. How many unknowns? 2. So that's solvable. Some forces in the X, some forces in the Y. Which one do you want to do? X, because that means this X component of AI, it's got to be 10, right? Yeah. So now it's like, oh, I need some angles. I think this is a 45, isn't it? Yeah. So we have 45 degrees. So that means that the Y component is 10. Oh, now we're cruising. Life's getting easier. And if I got 10 coming down, 14 going up, how much does AB have to be? 4. And I was right, it's got to be coming down to balance everything out. So just kind of look for that, because I solved it without having to do a cosine or a sine or a tangent or any of that monkey business, right? Because I could just see it in X direction and Y directions. AB equals 4K, compression or tension? Compression. Wow, that's one of the 4. This is great. Somebody said this is a long problem. You should make it like worth 20 points or something. Don't you think? 30 points, 40 points because it was 4 members. You guys got to get better at your negotiating. All right, now what? Just like take a break, have dinner, and come back to the problem? That's what I would say. How about, how are we going to get CB? Yeah, Let's do a cut. We know all this mumbo jumbo down here except for IJ, but we could get IJ or JY pretty easy, couldn't we? What's JY equal to? We know this is 14. Yeah, 14 up, 24 down. So right there, I just switched to, put it all back together, right? Put it all back together, 14 up, 24 down, 16 down. This should be 26, I believe. All right, so now let's do a cut. So the obvious cut is just straight through it. I can only go through 3, so I'm just going to cut horizontally. And which side do you want to work with? Bottom half. Why not? So that means draw everything that you cut as a vector and focus in on the one you want, which is CB, right? CB, BH, HI. And we're just looking at the my fancy ripped piece of paper. We're just looking at the bottom. Or did you say the bottom or the top? You said the bottom, right? Yeah. How can we go directly to get CB? Yeah. Moment about H drops these 2 out. This will be my only unknown. Yes, moment, no moment. Right? Goes right through the point. All right, let's do it. Red's dying on me a little bit. This will be a moment about H. So it's CB, this one, times this distance. Okay. Rotation, negative. AX, which is 10, times 16, rotation, positive. AY, which is 14, times 8, and rotation, negative. And JY, no. Anything else? I think that's it. So I'm going to take this statement, move it to the other side. That makes it positive. So I've got 10 times 16, that's 160. I get 6. I get a positive 6. That means CB is going in the correct direction, and it is in tension. So kind of a lot of talking and a lot of thinking, but one equation got it for me. Once I finally cut it, picked the right spot, got it. We still need this thing, CE, a bit ugly, and EH. Thoughts on how we're going to get there? Oh, sorry. Cut it again. So these 2 are gone. Like we can think about like, oh, my truss really looks like this, right? Yeah. So I'd kind of go for like a cut like this. Because this isn't here. I'm only cutting through 3, 1, 2, 3, and 2 of them are something I want. That makes sense? Which side? What about just using this side? Not this like mess down here. So if we do that, it's going to look something like, I'll actually make it a 45 this time. Maybe 45. E, F, G. Oh yeah, that's good. That's the structure. And we have kind of unknown here, unknown here, unknown here, H, G, E, H, C, E. And then we have 10K. You can't forget those externals. That will definitely mess things up. It did drop this because it's 0. So that's not there. I forget anything out of there? You know, this is 8. This is 8. We know these come together. Sometimes this helps. That's point H. And I think that's C. So sometimes it helps because you might do a moment at one of those spots, you know, to eliminate things. But what we want to know is this one and this one. Ideas. Okay. I'm going to leave them this way and let it go negative, and then I'll flip it. Okay. I think you're probably right. Some forces in the Y. How many unknowns would there be? 2 unknowns. I like it though. Good idea. How many unknowns? It's got to be a moment. Yeah. Now is the tricky part. You got to pick a spot that eliminates 2 of the unknowns for the moment. H. If we do the moment here, what drops out? True. And we're left with CE at an angle. So we would have to do CEX, right? And then CEY would drop out. That makes sense? Yeah, so I'm looking for a simpler spot. What spot did you say? E, yep. So if we did it at E, what drops out? And we get HG, but we don't want HG. Although that's a good move. I would go that way for sure, but there's even a better spot. Yeah. What drops out? Yeah, and we're left with EH, one of the ones we want. So it's like keep searching, keep searching. Let's go moment at C. None of your suggestions are bad. They would all work. It's just going to be a longer path to get to the thing you want. Okay. But all of those work fine. All right, moments at C. EH times 8. Rotation, because I drew it down, rotation is negative. What else creates moment at C? 24. That's also times 8 and negative. What else? 16 times, yeah, be careful, yep, 16. And then the rotation is negative, clockwise. Yeah, Junior's jumping around on me. He's trying to make me miss the 10K. But we can keep up with him. 10K times, yep. And the rotation. Yep. All right, let's just make sure we got them. We got the EH, we got the 24, we have the 10K, we have the 16, and then those two drop out. Anyone else get 46K? I get negative, which means EH is going the wrong way, which Junior already said that. I just didn't believe him. EH goes up. That changes EH's sign. We want to make sure we change that in the formula and then get this positive, and then it makes it compressive, right? We are left with 1 to get, and that's CE. How should we do it? Absolutely. Some forces in the Y. And we just like start totaling them. 24K down. 16K down. EH up. And I'm actually going to write it in as CEY, and I have it going down. That's the Y component of CE. Anyone get that to be 6? Yeah, I get it 6 positive. Y'all get it 6 positive? All right. So that means CEY, because I assumed it going down, I put it in as negative, right? So it comes up positive, which means my direction's good. It's down. Right? And it's 6K, and I know it's 45, so we got 6 and 6. So we should be able to just Pythagorean that out. .48, 8.49, if I round it, I guess. CE equals 8.49K pointing away, which means tension. This is what a structural engineer does. You just did it. And if you had a bachelor's degree and then the structural engineering license and you were a professional engineer, you could bill that out at a lot of money per hour. This is what they do. And they do a lot of other things, but trusses is a big thing. Like, I don't know, I'm sure you've seen them hauling down the road. Trusses are in everything, whether it's a structural steel truss, which is a horizontal top, horizontal bottom, and a bunch of diagonals, or whether it's a roof truss, right? This is what they do. This is how they run it, how they determine what the load is. So, very good job. We will stop this. That was a long one.